Hello everyone, welcome to the Electron Flow Academy. So today we are going to discuss about the numerical problem number 1 based on the transformer's EMF equation. Okay. So question is as follows that a single phase, this is the phase, sorry, a single phase 50 Hertz transformer has 30 primary and 350 secondary turns. Okay. Then the net cross-sectional area of the core is 250 centimeter square. If the primary winding is connected to a 230 volt 50 Hz supply, then there are some parameters we need to calculate. First one is the peak value of the flux density in the core. Second one is that secondary induced EMF. Third one is that what is the primary current when the secondary current is 100 ampere. So while calculating those parameters, there are some consideration which is mentioned in the question is that neglect all losses and leakage flux. Okay. So let's start the solution. Okay. So firstly, I am going to write the given parameter to us. So given is that E1 meaning the primary voltage. Okay. That means 230 volt. Frequency is 50 hertz. Number of primary turns is 30. Cross-sectional area of the core is 250 centimeter square. That means if I convert in the meter square, then 10 to power minus 4 meter square. Okay. And another parameter is like N2 is equal to 350 turns. Okay. So here let assume let PM be the peak value of flux density. Okay, then we know the EMF equation of the transformer is given by 4.44 F into BM into area into N1. Okay, so this is the formula. So from this formula, if I need to calculate the BM, then the value will be equal to E1 divided by 4.44 into frequency into area into N1. Okay. So this is how I am going to calculate the value of the flux density. Okay. Which is equal to Bm. So let's put the values here like E1 is given to us is 230 divided by 4.44 into frequency is 50 into area is 250 into 10 to power minus 4 into N1 is 30. Okay. So after solving this, the value of the flux density Bm is equal to now 1.38 Tesla or Weber per meter square. Okay, this is the unit of flux density. Okay, so we have calculated the first value, the peak value of the flux density in the core. Okay, so let's move on. Next parameter which is asked. So here we know that transformation ratio which is equal to K denoted by capital K is equal to E2 divided by E1 is equal to N2 divided by N1. So we have the both number of turns of primary and secondary. So let's put the value. N2 is 350 and N1 is 30. Okay. So from this expression, I can calculate the value of E2. E2 is equal to nothing but the K times E1. Okay. So which is equal to the value of the K is the ratio. Okay. And we know the value of the E1 we have just calculated here, or this is sorry, this is the given in the question which is equal to 230. Okay, so K 350 by 30 into E1 which is given to us is equal to 230. So now the value of the secondary induced EMF which is equal to E2 is equal to 2683.34 volts. Okay, so second parameter is also calculated here, secondary induced EMF. Okay, and then lastly, next parameter is, so here there are some assumptions, like since transformer is ideal. Okay, because the question in the question there is one consideration that no leakage, flux, and no losses are there. So that means the transformer is ideal. So that means the value of the E1 into I1 is equal to the E2 into I2. Okay, so power of the both primary and secondary is equal to. Okay, and we need to calculate the primary current when the secondary current is 100 ampere. Okay, so I1 when I2 equal to 100 ampere. Okay, so from this expression, I can rewrite this like I1 is equal to E2 divided by E1 into I2. Okay, so now we have the both values E2 and E1. Okay, so the value of the I1 is equal to, I'm writing here, I1 is equal to 350 divided by 30 into 100. Okay, we can rewrite also this equation. We can also rewrite this equation like N1 I1 is equal to N2 I2. Okay, so I am using the values of the number of turns here. Okay, so the I1 is equal to nothing but the, let me correct from here, I1 is equal to N2 divided by N1 into I2. Okay, so I am using those parameter here. So actually the value of the I1 from this expression is 1166.67 ampere. Okay, so this is how I have calculated the primary current. Okay, when the secondary current is 100 ampere. Okay, so this is how we have calculated the parameters asked in the question. So thank you very much. Please like and subscribe our channel.